Hello, it's Mr. Quaddy here, and today we are going to be learning about logarithms. We're finally going to be learning this new function. So to start off, let's just look at this question here. 7 to the power of what gives me 2,401? I want you to, when you look at this, obviously you think those words. 7 to the power of which number gives me 2,401? This has been a problem for us, right? Our whole math career. I don't know how to do that. The only way I really know how to solve a question like this is to try guess and check. So 7 squared is 7 times 7, that's 49. So it's not that. What about 7 cubed? What's 7 times 7 times 7? What's 49 times 7? I don't know that one in my head. 343. Okay, it's not that one. It's getting closer maybe. 7 to the power of 4. 7 times 7 times 7 times 7 times 7. Oh, there we go. So therefore, it's a power of 4. Well, what we just did, we just found a logarithm. Your first logarithm. Specifically, what we found was log of 2,401 base 7. So logarithm, this really an exciting sounding word, is really just a way of solving an exponent where we don't know what the power is. We're finding what number to the power of 7 gives me 2,401. So let's define this. Let's write this out in math lingo. If I have a to the power of x is equal to some number b, then log of b base a is equal to x. What we see is that exponents and logarithms are actually two sides of the same coin. They're actually inverses of each other. Actually, if you really want to hear something interesting, the logarithms were discovered in math before exponents. If you have an exponent, so base a to the power of x equals some number, I can rewrite this as a logarithm. So I have a logarithm of a number with base a is going to give me x, that exponent. So a few things to note here. First, this is called the base, and it's the same base. So whatever is the base of my exponent is the base of my logarithm. This is called the argument. A few other things. A should be greater than 0, and B should be greater than 0. They should both be positive. So you can take any exponential equation and rewrite it as a logarithm. Let's try doing this one. 2 to the power of 5 is 32. So I would write this as log. Remember, the base is the same, right? A, so this is base 2. It's a small 2, and it's kind of sunken. And then instead of putting 5 here, that goes to my other side. My argument is the larger number, and then I put the exponent on the other side of the equal sign. The way we read this is log of 32 base 2. And that's it. So the hardest thing with the logarithm is looking at this and realizing that it's just a number. And then making up math is the other big problem. So we're going to spend a lot of today just getting used to this notation. And really, if you ever get confused in a logarithm, just go back to this definition. You can rewrite an exponential as a logarithm or vice versa. So look at this question. This is saying log, okay, so 5 to the power of what equals 125? You can think of it this way, right? Log, well, let's go back here. Log 32 base 2, it's a number, it's 5. If you went to the top of the school and shouted out, hey, what's log 32 base 2? Someone would shout back to you, oh, it's 5. Similarly, when you go to the top of the school, you could shout, what's log of 125 base 5? And you're going to have to wait a while, but someone's going to respond to you. And how is that person going to figure it out? Well, they're going to rewrite this question by thinking, well, let me rewrite this as an exponential. So my base is 5. Actually, sorry, I'm just going to write it in words. What power of 5 gives me 125? So we have essentially the same question we have at the beginning, right? 5 to what power gives me 125? In other words, and this is probably more useful to write, 5 to the power of what equals 125? Look how I use my definition to rewrite it. So the base is 5, base is 5. This argument becomes, goes to the other side of the equal sign. And then whatever is on the other side of the equal sign, the unknown, becomes my exponent. So that's really what this logarithm is saying to me. Well, now it's very clear that question mark is 3. So I would say if you went to the top of the school, what's log 125 base 5? Someone would say 3. And you'd say thanks. Okay, let's try this one. So log 100 base 10. So think. What is it? You want to know if you shout it from the top of the school. Well, 10 to the power of what gives me 100? And you clearly know that 10 times 10 is 100, so the answer here is 2. Log 100 base 10 is 2. And that, I think, is one of the harder things for students to get their heads around when we do logarithms. Again, log of 100 base 10 is a number. Okay, let's keep going. Log 16 base 2, well, let's do another think. 2 to the power of what gives me 16? And that's 4. Finally, over here, think 4 to the power of what gives me 16? Well, that has to be 2. So it's not enough to just have log and an argument. You also have to specify the base. As you can see, it's different. Log of 16 can be different depending on what the base is. Just like 2 to the power of something is different than 4 to the power of something. Okay, there's a few special cases. We're going to get them out of the way, even though we've just been introduced to this idea. What if I have a situation like this? Log 2 base 2. Again, with logarithms, the best thing you can do is rewrite the question. So 2 to the power of x is equal to 2. Well, in this case, then, x has to be 1. So my first special case is if you have a log of a number where the base and the argument are the same, it's always going to be 1. Seems to have misplaced my rule. Oh, there we go. Okay, what about this one? Log 1 base 7. Okay, well, let's rewrite it. 7 to the power of what gives me 1? Well, in this case, x has to be 0. So another rule. If I have log of 1 with any number as its base, that's always going to be 0. Again, if you went to the top of the school and shouted, what's log of 1 base 1 million? Someone's going to shout back very quickly, 0, because that's an easy one. Okay, we have this question here, log with -8. You should remember from our definition that the argument should be positive, so you know there's going to be trouble here. 2 to the power of x equals -8. You can see that this is impossible. There's no exponent that will give me a negative here, so x does not exist. We should have known, because we can only find a logarithm of a positive number. Okay, what about this one? Log of 0. So that's going to be 5 to the power of x is equal to 0. What number? Oh, this is impossible. There's no number that will give me 0. So x does not exist. The argument must be positive. And finally, we have this question here. Log of a power with a base, the same base. Well, let me rewrite this. So it's going to be a to the, so this base, the power of x, is equal to a to the n. Now I know that if they have the same bases, I can set these equal to each other. So in other words, x is equal to n. So I have this very odd situation where if I have log of an exponent, where the base of the exponent and the base of the log are the same, then they kind of undo each other, and my answer is just n. Remember, and we're going to look at this more tomorrow, log and exponents are inverses of each other. So an exponent and a log undoes each other, and I'm just left with the original. I'm just left with this number here, this argument, or this power. So log of a to the n base a is just equal to n. And similarly, a to the log base a n is just n. Similar thing, if I have a to the power of a log, the log and the exponent undo each other, and I'm just left with the variable. Okay, now you have a log button on your calculator. You actually have there are many different logs, as we've seen here, right? You can have log base 10, log base 5, log base 6, log base 100. There's a lot of different combinations. Your calculator only has 2 logs programmed into its memory. There's my log button there, and when I press it, I see log, and I can type in any number I like. But wait a sec, I always told you there had to be an argument, or sorry, there had to be a base, and there's no base here. When you use the log button on your calculator, it's always assumed to be log 10. So log base 10, we write this as log a. You don't include the base. If you ever see log with no base, it's assumed that you're looking at log base 10. So if I were to type in log of 100, which we did earlier, the answer is going to be 2. See, my calculator knows it. So I don't have to go to the top of school and yell it out. I can just type it into my calculator. The other special logarithm that's in your calculator is the log that has base e. Do you remember what e is? Thank God we did a whole activity about it. E, Euler's number, is that special number 2.178. Has to do with, it's the natural exponential, has to do with compounding, infinite compounding periods and how things grow. It's when you see E, you should just think it's 2.718. This is also programmed into your calculator. It's written as ln A. So this button is also in my calculator. The ln button, ln. This, when you use this button, it means log base e, or log base 2.718. And so we pronounce it ln a. And remember, this is the natural, or this would be called the natural logarithm. Base e equals 2.718. Just like it was called a natural exponent, when you write ln a, it's called a natural logarithm. When I went to the University of Waterloo, I was in the engineering faculty. We had a really neat mascot, which was a giant wrench. In the math faculty, they had natural log. So they actually had a log. That was one of their mascots. Named after this thing, this law in A. Okay, let's turn the page. So this is my, we're going to do lots of practice now, but again, I'm going to say this one more time. I'll say this a million times this chapter. Don't panic when you see a logarithm. It's just a number. You can usually calculate it using your calculator, or again, what I like to say is stand on the roof, and you can say, hey, what is log 1,000 base 2? And someone down below is going to say, oh, sorry, log 1,000 base 10, and someone's going to say, it's 3. Okay, so just remember, it's always going to be a number. It's some real thing. So when you see this, you shouldn't panic. You shouldn't think, oh, I have to divide by log, or no, it's some sort of number. And the way we get through it is we rethink the question out. I always recommend, especially since you're going to forget how to do these questions, feel free to use my strategy here. 6 to the power of something is equal to 36. Now it's easy. 6 to the power of what? Oh, it's 2. What about this one? Log 38 base 6. Okay, well, you could go to the top of the school and yell it out, but let's see if I can do it myself. 6 to the power of what is 38? Well, now we get to the problem I've kind of been anticipating this whole time, is what if I get log numbers that don't have perfect, that don't work out perfectly? I don't know what 6 to the power of whatever gives me 38. It's got to be 2 point something. And I can't use my calculator, really, because my calculator only works with log base 10 or log base e. Now, we could go online, we could use some more powerful software. I actually could use my GDC, my graphing calculator, which can do this. Oh, well, it can do a lot of complicated things here. Let's clear that out. Clear history. Okay. I can actually type this into my calculator. It's a little bit more powerful if I remember where. So it's log. It can do any base. 6, 38. So it's 2.030. The point is it's still just a number. And this highlights kind of the two types of IB exams you might have. This would be a non-calculator exam. And I would call this an exact solution. This would be on the paper 2, a calculator exam. You can't figure this out yourself, so you'd have to use a calculator. And I would call it an approximate solution. Approximate because this is actually more accurate. This number, 2.030, we know there are numbers that come after it, so it's not really 100% true. For the calculator exam, and we'll talk about this more, we actually would only ever write 3 significant figures, so you wouldn't actually write the 0 down. 2.03 is 3 significant figures. Okay, what if you went to the top of school and said, what's log 17? Well, we know that log 17 is missing. It doesn't have a base there. The base is implied to be 10. And 10 to the power of what gives me 17? Oh, I don't think I can do that myself. So I'm going to get my regular calculator out and just write log 17. And there we go. We got our answer, approximate answer. 1.23. What about ln 17? Well, I see ln and I panic. Oh wait, I know what this is. This just means log base e 17. Or if you like, log 2.718 17. Okay, well either way, the number on your calculator is solved. You can't do this in your head. You have to use your calculator. Ln 17 is very easy, right? Just type it in. 2.83. Okay, I've included some practice here. Feel free to pause the video now and try them yourself. And then you can come back and we can try to go through them together. So good luck on these questions. Okay, welcome back from pausing the video. Let's try solving these. Again, when you see this number, this notation, you should assume it's going to equal something. Then you can rewrite it. I always do this little aside, especially when I forget. We haven't done these for so long. 6 to the power of what gives me 216? Well, 6 to the power of 3. Perfect. So this is equal to 3. What about log? Oh, geez, this is a decimal. Am I allowed to have decimals? Yes, I am. It just has to be positive. So this is fair. We could write this as log base 10, and this is 1/10, 100th. This is 1,000th. It's like that. So you have to think. 10 to the power of what gives me 1 over 10,000, 1 over 1,000. Or in other words, 10 to the power of what gives me 1 over 10 to the 3. Or 10 to the power of what gives me 10 to the negative 3. Ah, the answer is negative 3. Let me just check to see that that's right. Log 0.001. Ah, yes, it's negative 3. Wait, but I thought we couldn't have negative logs. Oh, the base can not be negative, and the argument can't be negative, but the actual log can be negative. So when you go to the top of the school, log of 0.001, you shout, what is it? Someone's going to say it's negative 3. You're going to say, what? But if you think about it, it's 10, like if the argument itself is much smaller than the base. So 10 to the power of what gives me a really small number? Well, I'd have to use a negative exponent. This will make a little bit more sense when we graph the function tomorrow. Log base 8, if you want to think about it, this is 10 to the power of what gives me 8. Eventually you'll be able to look at that and say, oh, there's no way I can calculate that myself. I have to use the calculator. Log of 8, because I don't know 10 to the power of what. And the answer is approximate 0.903, 3 significant figures. Okay, ln 3, I just type into my calculator, 1.10, 3 significant figures. And here, log 1, oh, that was some special case. Let's go back. Log of 1, doesn't matter what the base is always 0. So this is 0. If you want, I could rewrite it. 17 to the power of what equals 1. I'm just going to write special case. Now my nightmares are coming true. I have ln e. So, okay, let me rewrite this. I know ln is log e. Okay, so this really means e to the power of what gives me e? Well, this has to be 1. This is another special case. There was that last one. If you have a log where the base of the log is the same as the base of the exponent, then you just take the exponent's the power. So in this case, I had e base e, and this is a 1, so the answer is just cross these out, they undo each other, and you're just left with 1. Again, if you don't like memorizing the special cases, you can just go back to the definition of a logarithm. Write that out, that little thinking line, and you can figure it out. Oof, now we have a scary one right here. So I have log, all these hard things. So let me rewrite this. This is going to be 10 to the power of what is equal to 5th root of 100. Now the 5th root of 100, that just means 100 to the power of 1 over 5. This is tricky. Usually I can equate the exponents if the bases are the same, but they're not. However, I can do it. I can change 100 into 10 squared to the power of 1 over 5. So I get 10 to the power of 2 over 5. So therefore, I think I figured it out now. This answer is 2 over 5. That's a very tricky one. Okay, what about 4 base 64? Well, so this is going to be 64 to the power of what gives me 4? Ooh, this is another question where my base is a lot bigger than my than this number 4, so I assume this is going to be some sort of negative number, negative exponent. Let's see if I can figure it out. Well, I guess I can try to do what I did here, where I have the same base. 4 times 4 is 16, times 4 is 64. So 4 to the power of 3 is how I can replace 64 with 4 to the power of 3, and then I can replace this with 4. Well, just leave this 4 to the power of 1. So now I'm going to set the exponents equal to 0, I'm going to set the exponents equal to each other, so I have 3 times my question mark variable equals 1, so question mark is equal to 1/3. Maybe question mark probably isn't the best variable, I probably should have used an x. But either way, I find out that my answer is 1/3. This makes sense to me, right? We assume that because there is a larger number and a smaller number, that it's some sort of fraction. Just double check that one. We have log of 64, 4 base 64, and it's 1/3 indeed. There we go. Okay, what's next? We have log of 1 over 9 base 3. So let's think about this, another difficult one to think about. So 3 to the power of what gives me 1 over 9? Now if you want, this is 1 over 3 squared. 3 to the power of what? Negative 2, so therefore my answer is negative 2. These are all exact solutions. Why is this negative and this positive? We'll look at it more when we see the graphs, but because this number here, this argument is greater than 1, it tends to be positive. And now it's a small number because we have this situation where the base is very large. Over here we have a number that's less than 1, it's a fraction. Same up here, we have a number that's less than 1. In those cases we tend to get negative numbers. Okay, finally let's try solving some log expressions, and we'll do a lot more of these later in the chapter, but let's just get started. I want you to get used to looking at this and not panicking, because it's a lot of new notation. And there's a real tendency, what I hate to see, and I'll keep saying this, is when students say, oh, well, ln x equals 3. Okay, so what I see often when students get to this, especially when you forget how to do this at the end of this course, you get this expression, you're like, oh, okay, well, I want to figure out what x is. I'm going to just divide both sides by ln. So x is equal to 3 divided by ln, say ln 1. And they just type in random things like that into their calculator. And so this is not what we're allowed to do. When you look at this, you have to think, stop. There's only one definition for a logarithm, which is to link it to an exponential. So I'm going to rewrite this, log base e equals 3. So this is technically e to the 3 is equal to x. So the way you solve this question, you would be completely wrong if you did it this way. You have to rewrite the expression. And it's not that tough. E3, you could leave it at that if it was a paper 1, if you did not have a calculator. If you did have a calculator, you would use the E button. For me, I have to press Shift ln. And then you don't actually have to put the hat in. You don't have to type the power of sign. It's assumed. So I write E3 and I got this answer, 20.1. Look at this question. Again, there's a tendency to want to do BEDMAS stuff. This is grade 12 now, or grade 12 material. We're not doing BEDMAS. We have to rewrite this logarithm as an exponent. So 3 to the power of 2 equals x minus 2. It's so satisfying now. 3 squared is 9, so x is equal to 11. Okay, and our last question here, I have x to the power of 2 is equal to 9. This is very rare to have a question where you don't know what the base is. But I can, once I've rewritten as an exponent, I can solve this. I need to take the square root of both sides. However, remember, when you take the square root yourself, you have to do plus or minus. There are two answers. So your answer is plus or minus 3. However, the base must be positive. Therefore, x is equal to 3. Okay, that's our first day of logarithms. Hopefully you can take some time to get to know this notation. Again, it's not too new, the math isn't too new, the notation is what makes this very challenging. Your homework, I believe, is a page that I will attach, and good luck, and we will see you next time.